Okay, good afternoon, everybody. So let us start our class this afternoon. But I'm personally lucky and happy that we are at the we are in the last quarter of this course. Okay, and then we have completed most of the top and essential content of this course, and my section is little bit ahead than other sections. So if you need any help to review or recap the previous topics, so then we can do that. Anybody has any opinion that we need to review any of the previous topic? So at this point, how are you feeling about this course? Are you everybody happy? Everybody is happy with this course? Yes. How many of you are not happy still? Anybody is here? You're not happy? Are you raising your hand? I would like to make a statement. I would like to make a statement. I don't feel like it's a safe place for somebody to say this. So you're never going to get anyone. Okay, so then if you do not feel, then there is a way that you can give your feedback, right? You can give your feedback anonymously, or you can write your name, or you can, even I told you that I would not mind even if you tell me that I'm not teaching well and then something I need to do better. Yeah, please feel free to give your opinion. So we have covered, for the last 2 weeks, we have covered linked list and stacks and queuing, right? Linked list, stack and queuing, these are the different kind of data structure. So these are more likely, for instance, a linked list is more likely about a dynamic array. And at the beginning of, before I started linked list, I discussed array list. You remember that? Array list I discussed, although that is not in this topic, but that is an important topic, array list. So I like everybody to do some practice on array list. Array list is a dynamic array, and that is simple. In one of my classes, I showed some operation of array list. You yourself should, at this point, should go through. Okay, and then our test will be in next week, right? Yeah. Okay, next Wednesday. Okay, and before that, I posted some questions. One day 12 D12 discussion, right? Let me see how many of you have participated there. And as I promised, if I see that more people are participating here interestingly, then I will post more questions or discussion topic. Okay, so 26 post. How many of you are there? Maybe still 50% did not respond yet. Okay, by the end of this day today, if I see at least there are 50 discussion here, then I will post another question. Okay, how many of you have not seen this discussion topic yet? Okay, I wanted to post this, like for instance, if you get similar kind of questions in your upcoming test or even in your final, I don't like that you will do mistake again. Okay. So our today's topic is exception handling, an interesting topic. So let us start our discussion. Okay, an exception is an unexpected error or an unexpected situation that will occur in your program, and mainly that will occur your program execution time. Okay, so if there is some unexpected error occurs during your program execution. Unexpected means you did not expect, you did not realize. Okay, or even sometimes you did not have sufficient measures to resolve that issue. That are called exceptions. Okay, so in order to write a good program or a good application, we always we always to be careful about exceptions, and we need to handle exceptions carefully. So I believe there are some situations that, for instance, if when sometimes if while you are running a website, you are running an application on a web-based application, you may realize that the web sometimes the website crashes. That means it gets stuck or it unexpectedly closes. Have you ever faced that issue? Or sometimes you have opened an app on your mobile phone and without giving any warning, your app closes. It happens, right? And you're familiar with it. Okay, that happens due to exception and due to unhandled exceptions. That means an exception happened that was not handled carefully, or the program could not handle the exception, so it terminated the program. Or sometimes even if the exception is a major exception, a major problem, sometimes it restarts your computer. Have you ever faced that kind of? It rarely happens nowadays because the operating system is robust. So, but in future it happened. Sorry, in past, like even in past, like 20 or even 15, 20 years ago, when the operating systems were not too much powerful, then sometimes due to some unexpected program error, your computer was rebooted. Okay, so since it is not possible to handle or to remove all possible errors or exceptions, but it is possible to take measures or handle most of the exceptions or common exceptions that are frequently occur. So in this chapter we will learn what are the common exceptions and how to handle those exceptions. Okay, so let me tell you a story about exception handling in our real life. This is a kind of interview question. Sometimes some interviewer may ask you a question, okay, that give an example of an exception or an exception handling situation that has no relation with programming. Okay, I will tell you the story soon, but let me see that my okay. Before going to the story or the situation, let us see a simple program. Okay, so this program is pretty simple. Let us try to analyze this program. So it is a class name, like this is a class name. Okay, and it has a main method, and within the main method I have some variables, integer x, y, g, and d. And I have put x equal to 5, y equal to 10, then g equal to 15. Okay, then if I say d equal to g divided by 2 minus 2 times x, so then what will be the d value here? Can someone please help me? D will be, my g value is 15, right? Divided by, my y value is 10 minus 2 times x. What? Is 10. That means 15 divided by 0 is undefined number, right? A number that is divisible by 0. Okay. Then if I want to run this program, you see that this is my output, but this is an exception. Okay, it is showing me, you see the exception in thread main. Okay, this in main thread there is an exception. It's called java.lang.arithmetic exception. I will tell you later what is about arithmetic exception. And the exception name is division by 0. And it says an exception handling, this exception handling is my package name, and dot this j14_1, this is my class name, and this is my main method, and it has the line number 12. So it says on line number 12 there is an exception. So at this point you see that if an exception happens on line number 12, then whatever you have other lines or other statements after this line, this statement will not be executed, will not be reached. So this is why my simple output, okay, even I say hello friend, it will not be executed. So it was not executed. You see that my program terminated at this point on line number 12. When it came on line number 12, then my whole program terminated. So if would, if this program is a part of an application, of a large application, then at this point, when these lines of code will be executed, then the application will be terminated unexpectedly. Okay, because an exception happens here. So always remember that an exception is not a compile time error. So you understand that what is called a compile time error, right? Compile time error means if there is a mistake. For instance, if I say G2, that there is no variable or identifier as name G2. This is showing a compile time error. So before I run this program, I know that there is an error on this program, so I can fix it. But all exceptions are runtime error. All exceptions give runtime error, and all exceptions happen during runtime. So program compile time, you may not realize that there may be an exception. Okay, so in order to resolve this kind of or similar or other kind of exceptions, we need to add some extra codes in our program so that when an exception happens, so that we can resolve this issue, this exception, or we can avoid this statement, or we can bypass this statement, or we can skip this statement. So these measures are in general called exception handling. Okay, so now let me tell you my story. So I came up with this story. For instance, one time I was asked to, some interviewer asked me to give them an example of exception handling in real life. The interviewer told me that he did not know anything about programming, actually, but he was a real good programmer. Okay, but he wanted to justify me whether I understood exception handling or not. I was lucky that I gave him this example, and then he was satisfied. So let me tell you the story. So let us think about the situation like how roadway or highway about 100 years ago, or even still at this time, there are some highways single lane. There are some roads in single lane road. And for instance, this is a typical highway. And think about if an accident happened on the left lane. Is this the left lane or right lane? No matter. Okay, on the lane there is a large truck. Okay, so if there is an accident on this lane, so then what will happen? This lane will be blocked, and there will be a traffic on this highway or road. So then what is the solution? That other vehicle will use the alternative, this route, this lane, parallelly, or they share this line, right? Okay. So in order to resolve this kind of issue, in modern highways have multiple lanes. So first 1 lane, 2 lanes, 3 lanes. So if an accident happens on this lane, so then people will use other lanes. Okay. So this is a way that the modern highways are built with these exceptions or accident in mind, right? Moreover, in the modern highways, there is another lane that is called, what is called, emergency lane. This emergency lane is used keep free to be used by emergency like police or emergency ambulances or even fire trucks. If all of this lane blocks, if all of the lanes are blocked somehow, then this the emergency people, they use the emergency lane, right? So this is a typical scenario of exception handling in our real life. Okay. So we can use this metaphor in our exception handling purpose. I think I will come back to this slide later. Okay, my story is not finished yet. I will come back later. So at this point, we know that if we run this program, then there will be an exception happen on what line here in this, on this, according to this slide, on the line number 7, right? It's just line number 7. It's line number 7. Okay, that I showed also my line program here. So now at this point, everybody understands that what is an exception? An exception is an unexpected error that occurs during runtime. Okay. For instance, there is an exception in this program. So now, if we need to resolve this issue, so here, even here, I see that my g value is same, or actually my denominator is here 0. So even if I do not give the hard-coded value, if I would enter this value using keyboard, using scanner method, then it may happen. It might happen. If somehow my y value becomes equal to 2 times x value, then every time it would happen, right? So then let us see another program. Okay. Let us see this program. So this program is same of the previous program, but you see that this line where my exception happened, it is blocked with a try block. It is enclosed with a try block. That means that if this exception happens, then my try block will catch it, will realize it, and what will happen, and that exception will be caught by my catch block. And in the catch block, whatever I want to do, I will be able to do. I can just display an error message, or I can fix my program code, or whatever I want to do. Then in this way, if I run this program at this time, you will see that my program will not be terminated. To run this program. You see that at this point I have put my code, this line, within the try block. So then when the catch block, I put a catch statement, and then what happened, I will explain this every line, okay? And then what happened, I displayed some print statement, and then after that I changed my instead of making d equal to g divided by y minus 2x, I just made y minus x. So then there is no, even I can put this code even here. Sorry. Let me run this one again. Yes.
So do you have to, in the catch statement, do you have to put what kind of exception it would be? Like, so let's say we didn't know it was the arithmetic exception. We just put catch.
I will discuss about type of exception later. Okay. I'm giving just a scenario of an exception and how to handle it. Yes, you have a question?
Is it possible to just put the entire program within a try and then, like, put catches for every type of exception that could happen?
Yes.
I mean, wouldn't that, like, foolproof it from anything you just didn't think of?
Okay, I will answer your question 2 minutes later.
All right.
Okay. So what I'm doing here, for instance, I am putting my statement that might occur an exception within a try block, and then if I use that rule is that I have to use a try block, I have to put the code within try block, and then just after the try block I have to put some catch statements. The catch statement will do if the try block gets an exception. Then the catch block will catch that exception and handle it. Okay. So the scenario is like this. For instance, let us consider that when we drive in our daily life, if we see that there is an accident in front of us, then what do? We take alternative route, right? We take alternative route. Everybody understand? And sometimes we took a detour and we avoid that accident place, if there is a way. But sometimes there is no way. If there is an accident, if there is no exit point, you have to wait hours, maybe hours after hours, right? So there is no way in that case. But if there is a way to get an alternative route or detour, we do use that facility. Okay? But we do not do, for instance, do we do that at every stop or every point we stop our vehicle and we ask other people, hey guys, hey police officer, is there any accident in front of us? We do not ask them, right? If we find an accident, then we take alternative way, right? But at every point or every signal, we do not stop and we do not ask people, or we do not see. Let us see if there is an accident. We do not see that. Like he is asking, what's your name, please? John. Okay, John is asking a question that is it a good way to put all of the statements within a catch statement, right? Within a try block.
Yeah, and just have every catch possible.
That will happen that you are driving, for instance, you are driving even 10 miles, and then for instance, then you are driving 10 miles and there are some traffic light, stop light at maybe there are 20 traffic lights. So do you stop every traffic line and ask people or see or watch, is there any accident in front? No, we do not know. So that means it will happen that if you put all of your state programs code in that situation, in a try block, that will happen that you are watching at every point, every second or every moment. You are checking that if there is an accident, even you are asking yourself, do you do that? No. what will happen? That you will be distracted, right? It will take more time for you. It will delay your journey, right? So that if we put all of our statements in a try block, then that may happen. So for instance, we know that there is no way that these lines will occur any exception. So we should not put this within a try block. So even we can put this within a try block, but that is not a good way. You understand? You got the answer?
Yeah, it's just gonna take longer.
It will take longer time, and that is not a good way. Okay? And so this is a typical way to handle an exception is that most of the time we may realize that where an exception can happen. And when we will be an expert programmer, definitely we will know that there will be some statements for which there will be no exceptions. For instance, these statements. Actually, there are three statements here, right? 1, 2, 3. These are separated by semicolon. So these three statements, for these three statements, there is no possibility that it will happen an exception. So we do not need to put this within try block. But as you know that there is a division sign over here, and a divided by 0 can always make an exception. So this is why our concern will be about this line. So this is why we are putting in this line in a try block. Yes.
If you were to try all the things, come up with perhaps 2 exceptions, would you catch both or would only catch one? Sort of mystifying that there were 2 errors, but you only caught one.
Yeah, we will go through the in depth. Yeah, as many exceptions, as many doubt we think, we guess, we will put all of this in a major exception. We may have multiple try and catch statements, and we may have one try and catch statement within another try and catch. Sometimes we may have that. We'll go in depth. That depends on situation. But this program is very simple, right? For this one, it will not happen. Yes. You have any question?
Oh, I was going to say, but if the program finds an error, doesn't it stop there? I mean, how would it find 2? Right? Doesn't it? Like you're saying, like if it found 2 errors,
yes,
doesn't it stop at the first one?
Exactly, the first one.
Yeah.
But then if you have like multiple catch statements, you would, I guess, catch the first one and then say, oh,
And then you fix it.
the second one.
Yeah. Yeah.
So this is the way that when you write your try block, you will just put your code within try block, and you have to write your catch block nicely or very strongly or robustly, so that if the try block gets an exception, your catch block can catch that. We will learn that soon, okay? But thank you for your curiosity that you are interested to learn about this more, okay? So, someone asked, what is your name? Who has asked this question? There are several types of exceptions. For instance, arithmetic exceptions, that divisible by 0. Null pointer exception. Null pointer exception is sometimes that it may happen that we are expecting an object, but the object does not exist. For instance, if we want to find this length of a substring, but the substring does not exist, can we find the length? No. So then in that case, a null pointer exception will happen. There are sometimes called input mismatch exception. For instance, you are intended to enter an integer number, okay, but by mistake you give a character input or a Boolean input. So that will be input mismatch. Okay, one number format exception. We know that there are different number format: integer, float, double. That if that mismatch. Okay, and then another is more common exception is that array index out of bound. Sometimes if you have an array with 10 maximum size, if you want to access the 11th element or 15th element or out of range element, right, that will make array index of bound exception. I think many of you are already familiar with this array index out of bound exception, right? We will see. So in our exception handling, so this will cover at least all of these. These are the known exceptions, common exceptions. Our program should handle all of these exceptions. So now let us try how do we handle exceptions. So the pseudocode for exception handling is as for like this one. Is perform a task. Okay, and if the preceding task did not execute correctly, then perform error processing. That means what will happen if the previous task was not executed correctly, that means there was an error. So then in this block you will handle that error. How do you do that? And then after that you will go to the next task, and if then this preceding task means this task did not execute correctly, perform the error processing. So in this is a pseudocode. In this way exceptions are handled. So what are the advantages of exception handling? So exception handling enables programmer to remove error handling code from the main line of the program's execution. Programmer can decide to handle all exceptions of certain types or all exception of related type. I will go through this. Okay. So actually the first one is that we need to, instead of putting all of the codes in, handle all of the codes or put all of the codes in exceptions, we need to put only the suspected codes that may cause exception. Let me see. Okay, this is the code. This is the class hierarchy of Java. In our next class, I will show with C#. Okay, so this we know that object class is the top level class for Java, right? You know that, right? I think this is not a good way. I think this is a good way. We know that in the java.lang package there is an object class. We discussed that during our inheritance time. The object class is the great parent class, right? This object class has a subclass throwable. And throwable class has two subclasses. One are errors and another is exceptions. This exceptions class has other two subclasses, runtime exceptions and other exceptions. Okay, so there are other complicated hierarchy of this. So now let us go through this one. This one is more complicated, right? So in the exception class, there are runtime exceptions. The runtime exception has this kind: illegal, argument exception, and then index out of bound exceptions, and it has another subclass array index out of bound exceptions, and runtime exception has another arithmetic exceptions, and illegal argument exception, it has another number format exceptions. And you see that these, although it is complicated, but this is a complete structure of exception, different kinds of exceptions. Okay. And in the C sharp, likely similar to Java, in C sharp, there is also exception handling hierarchy class. So the top one is exception class, and then it has application exceptions, and it has system exception, and it has some other subclasses, but these are not shown here. Like there are many other subclasses like here. In my next class I will try to update this slide. So this slide, this says how to handle the exceptions. These are the main thing. Inside the try block, this is in C sharp or C sharp, Java and C sharp allow us to intercept and handle some of these exceptions using try and catch blocks. Using try and catch block, we can handle some or most of the exceptions, but not all. Remember that although programmers take many measures to handle the exceptions, to remove the errors, but still there are some errors in application. No application can claim that there is no error in this application. So what is the way that I already showed in the program? Inside the try block, we put the code that might generate an exception. And inside the catch block, we put the code to handle any exception that could be generated. So the main thing is that in the try block, we will put the code that might generate an exception, and after the try block, we will use at least one catch block that will handle the exception that is caused by the exceptional code, and within that we put in the try block. So if you do not put any code in the try block, you cannot use any catch block. So the catch block is associated with the try block. Okay. So I will come back to this program. So this is a try catch syntax. So within the try block, okay, we should use curly brackets. Within the curly bracket, we will put the code that might generate an exception, and within the catch block, we will put the code to recover from exception. So what will happen if an exception occurs in the try block? Control jump immediately to the catch block. What will happen if your code in the try block gets an exception? Then your control will not execute that statement, rather it will jump to the catch block. Okay, but if there is no error occurs in the try block, okay, then your control will not go to the catch block. For instance, let me show my program again here. So if my code does not make an error, if I say plus sign over here, it will not create an error, right? It will not make an exception, right? So Then happen that what is doing here actually is I moved my code over here, so it is not getting. Okay, you see that. So since this statement did not make an error, so it did not go through this code. So why it showed me d equal to 0? Because it did not calculate d. So you remember that I have d something, right, other than 0, right, here at this point. So but it showed d equal to 0 because since an exception did not happen here, so it did not execute this statement. It just jumped to this way. So at this point my d equal to 0. Initially 0, or let us put this a different value, for instance 5 initially. Then it will print my d equal to up. What is my d? Oh, I see. I will discuss this later. Okay, I have a few minutes. Let me finish my story. Okay, so my catch block will catch the exceptions that occur within try block. So according to the exception type, I may have multiple catch statements. Okay, and in addition to the multiple catch statements, I may have a finally block. Okay, the finally block executes if none of the catch statements happen, or if even if the exception does not happen. So with this scenario, with this combination of try, catch, and finally block, okay, a full try, catch, and finally statement will be like this. Syntax will be like this. There will be a try block, and within the try block, the code that might generate an exception will be put over here, and there will have multiple one or more catch statements. Okay, according to the exception type, you can put exception type over here within the catch block with exception type argument. So if this type of exception happens, this catch will be executed and other catch will be skipped. If this catch type is happened, this exception type is happened, then this catch block will be executed, and you will put a finally block at the end. Finally block will be executed no matter whether you get an exception or not. Okay, so the finally block is like this way. For instance, if there are some Java code, if an exception occurs, then it will execute, it will go to the exception handler, okay, and exception handler, if even it handle it or do not handle it, okay, then the finally block will be always executed. The finally block will always be executed no matter whether an exception happens or does not happen. So now let us go back. Let me give 2 minutes, please. Let me still finish my story. We are back to our real life highway story that we are discussing an exception, right? So here each of the lane is a catch block. Each of the lane is a catch block. That means if an accident happened on this lane, on the leftmost lane here, or you say right or left, I don't know. You say this left lane. Then if an exception happened on this lane, an accident happened, then people will use this lane, right? Second lane. If both of this lane are blocked by an accident, then people will use another lane. But you see that we have already an emergency lane that is more similar to the finally block. No matter whether there is an accident or not, my finally block or my emergency lane over here will always be free, empty, right? So this finally block will be used or executed even an accident happens or does not happen. For instance, in our real life, we see that this emergency lane is used or keep free even an accident happens or an accident does not happen. Okay. So in our next class, we will discuss more in depth about exception handling. So see you then.